Okay, sometimes confusing idea is the sign of the acceleration. And so basically when is it that the object is slowing down or speeding up? So there are four cases, and let's go one by one. So we have the case in which the velocity is positive and the acceleration is positive. Now we have the case in which velocity is negative and acceleration is positive. And then we have the case in which velocity is positive and acceleration is negative. And finally, we have the case in which velocity is negative and acceleration is negative. Let's see what happens in each one of those cases. If the acceleration is positive and the velocity is positive, then you can think of the velocity versus time graph as a line with a positive slope. The speed increases. So you can see here on this motion diagram that the speed is increasing. If the acceleration and the velocity are both positive, then the speed is increasing and the object is moving to the right. What happens if the acceleration is still positive, but the velocity is opposite, is negative? In that case, the object is going to be slowing down, right? So here you have a positive, still a straight line, but the velocity is negative. Notice that the velocity, in this velocity versus time graph, the line is below the axis, is negative. So the speed is decreasing because it's going from a higher speed to a lower speed until it reaches zero here. The slope of this line is zero. It is positive, sorry, is the acceleration here, which is positive. So in the other two cases now, we have negative acceleration. You can see both have negative slope. So if the velocity is positive and the acceleration is negative, then it's slowing down. Eventually it's going to reach zero. The slope is negative. And in the final case, both negative. So the slope is negative here and the speed is increasing, but it's increasing, the velocity is increasing in the negative direction. So another way to think about this is if both the speed, the velocity and the acceleration are in the same direction, like this one here and this one here, the object will be speeding up. If the velocity and the acceleration have opposite directions, like this one here and this one here, then the object is going to be slowing down. So this could be tricky. So here we have a motion diagram, right? And so we have the acceleration pointing to the right, it's a positive acceleration, and then we have the velocity pointing to the left. So the motion diagram shows that this particle is slowing down. So would you say from there that the acceleration is positive, is negative? The object is slowing down. What is the sign of the acceleration? So, and if you think about it, if you thought about it, then it's gotta be positive, right? So why is that? Okay, let's just plot a velocity versus time graph here. So here, this is time, this is velocity, and then the velocity is negative. That means it is under here, right? It is on this quadrant. So, and it is slowing down, so it's going from a higher speed because you see this is, for instance, this would be -1 meters per second. This would be -2 meters per second. This would be -3 meters per second. So as you go down, you're going faster, but your velocity becomes more negative. So if your velocity has this shape, then the slope of this graph is a positive number, right? but the speed is decreasing. It's going from, say, from here, from 3 meters per second to almost 0. The velocity here, velocity is going from -3 to -1. So the object is slowing down because the speed is decreasing, but the acceleration is positive. So the acceleration causes the object to slow down. So we have another example here. We have Mike jumps out of a tree and lands on a trampoline. The trampoline sags 2 feet before launching Mike back. What is the acceleration at the very bottom? So take a minute to answer these questions and then come back with the answer. Okay, if you thought about this, then at every point this trampoline is going to be pushing upward. So Mike, the acceleration at every point is going to be upward because, well, when he's coming down, let's draw a motion diagram. He's coming down, right? So he's coming down. This is a motion diagram until he goes to stop, right? So these are the velocity vectors, and the acceleration points up here, right? Slows down Mike. So now he's gonna go up, right? So he starts here, from here to here, then here, then here, and then there. So the acceleration is still positive. So the acceleration is positive at all times. So let's do a final question here. So we have a car that slows down while moving away from the origin. So it's moving that way, but it's slowing down. So what do the position and velocity graph look like? Take a minute to answer this question. Okay, if you thought of D, that's the right answer. So this graph here, this is position versus time, right? So you can see that it starts at 0 and moves away from 0. But then as it does, it kind of plateaus here and then it stays there, right? So slows down. So the velocity starts at a high value here, right? Slope of this, but then eventually it becomes horizontal, so it goes to 0 at that point where it stops. Right, thank you.